All right, what I want you to do is we're going to go ahead and continue working with the standard form for parabolas. So it's going to go with that 10-2 section that we worked on yesterday. So we got two more problems that we want to kind of work through here. They do involve a little extra stuff that we did back from first semester. So I'd suggest take out your notes. Let's go ahead and just continue with those 10-2 notes we started working on from yesterday. But my suggestion would be is that as we work on these two problems, make sure that you're kind of checking back in your notes for these two different forms for our parabola. All right, I want you to copy down the first example that we're working on today. However, this is really the second example because we worked on one yesterday. We took that equation, the y equals negative 2x squared, and kind of worked with that one to get it into the proper form. So it's still going to be the same example we're working on here. So still want to find the focus, the vertex, the directrix. However, we've got a slightly different form that's here. Now, the first thing we should probably check is just to make sure, do we have a vertical or horizontal axis for this one? Easiest thing we can do is just kind of match up whether our y is squared or whether our x's are squared. And if you notice right away, our y is squared. So if you look to those forms from yesterday, what you can see is that we're going to end up having that horizontal axis, which implies our directrix is vertical. So our parabola is either going to be opening up to the left or to the right. So it's going to be on its side from where we're used to seeing it. It's not going to be a function, but as we said yesterday, we don't care if it's a function or not with these different conic sections. Okay. So we need to try and match this up as best we can with the example in terms of the standard form. So in order to do so, it's actually going to involve just a little bit of work we did back from first semester, which is completing the square. So let's just try and isolate our y's and our x's. Let's get all of our y's on one side, all of our x's to the other. You'll notice really the only thing we have to do to accomplish that is add the 4x to both sides. So when we add the 4x to both sides, we end up getting y squared minus 4y equals positive 4x. Now, you'll notice it's this expression right here that we've got on the left-hand side. That expression that says y squared minus 4y. Really, this is the expression that we want to focus on. And I'm just going to add a quick note off to the side here that we need to complete the square. Because what we want to be able to do, and even if you look back to that, the standard form for the polynomial, or for the parabola, sorry, the standard form for the parabola here, you'll notice that we want to have that y component be squared. We want to have an x component really kind of by itself in this case. But it's not going to be just as simple as just factoring this or pulling out a common factor. So we have to complete the square. So if you remember those steps, I'll try and explain those one more time as we go through. What I always like to do is let's put that y squared minus 4y plus, we need to kind of fill in the blank here in order to complete the square. And if you remember our shortcut that we talked about in order to complete the square, it's this. Take that b value, which is going to be the coefficient of y, and we're going to take half of it. So take negative 4 divided by 2, which is negative 2, multiply it by itself, and then we get the number that will complete the square for this section, for this expression. So half of negative 4 is negative 2, multiply negative 2 times itself, and that will be 4. So 4 will complete the square for us. Now if we add 4 to the left-hand side of our equation, we have to make sure that we add 4 to the other side to keep the equation balanced. So we're also going to have 4x and we're going to add that 4 to the other side as well. Now what that allows us to do is this. We can factor the left-hand side now, and since we've completed the square on it, we're going to factor it as a perfect square. And remember the shortcut on this one is we're going to have that particular factor here that's going to be squared. And the way we can fill in the factor is simply this. We know that the y times the y is going to have to give us the y squared that's here, so we're going to put y there. But the quick shortcut to find this constant that gets added or subtracted on the inside is simply taking half of the b value, which would be minus 2. And if you multiply that out, you'll notice that the minus 2 plus itself gives us minus 4. Minus 2 multiplied by itself gives us the positive 4, so if we were to distribute, we'd get the same expression. Equals. Let's go ahead, and what we need to do is start to kind of unwrap this p value, which tells us the distance between the focus and the focus and the vertex, and the distance, same distance between the vertex and the directrix. So let's just simply factor so we can kind of get that second component there. And we'll notice that there's a 4 that can factor out of each of those two terms. So if we pull out that 4, we've got 4 times the quantity x plus 1. Now, if you're looking at that form, actually we've got everything set up perfectly now because we've got our y component that's being squared, we've got our x component that's over here, it's not squared, but we've also got this coefficient, you can kind of think of it as a coefficient getting multiplied in front. And it was this coefficient, yesterday we tried to match up with that form, okay, for the standard form, and what we saw was this, and we haven't talked about why it's 4p, we just said we have to accept at this point that this value of 4 is going to equal 4p, and that will allow us to solve and try and find what the p value is, and that value of p simply, like I said, represents the distance between the vertex and the focus. So divide by 4 on both sides, and we get the p as 1. All right, let's go ahead and pick up kind of where we left off. We've got it into the form that we want to see. So let's start pulling off some of those different values. The first, and probably the easiest one now that we've got it in the proper form, is our vertex. So if we notice, we have to be careful here because now we got to match up the x-coordinate of the vertex, which should be in that expression that has x in it, which is over here. So our h value we're going to pull from that right-hand side, which has the expression x plus 1, and the k, which is going to be the y-coordinate of the vertex, we're going to pull from that expression that has the y minus 2. So if we come up to the side here, we'll kind of keep track of all these different things that we've got going. So our vertex is going to be at the ordered pair. Now be very, very careful of the x value, or the x-coordinate, because in the form it says that it's x minus whatever h is. So what number do we have to substitute in to be able to get x plus 1? That's going to have to be a negative 1 for the h. So it's going to be negative 1 for the x-coordinate. Now the y-coordinate for our vertex is a little bit easier. We can just pull off that value because it's minus 2. Our y-coordinate is going to be exactly 2. So the vertex is at negative 1, comma 2. Second step, let's go ahead and find the equation for the directrix. Once again, if you look back to your notes from yesterday, we've got a quick and easy form which we can use to find the equation of the directrix. However, since our axis ended up being horizontal in this case, we got to make sure that our directrix is going to be a vertical line. So it's going to have to start with x equals. And if we use that form, we saw yesterday that we were going to take x equals. We had to take the x-coordinate of the vertex, which is h, and subtract p, which told us the distance between the vertex and the focus. We know all those values from our work we've already done, so our equation is going to be h, which we found was the x-coordinate of negative 1, minus our p value was 1, so this would be a vertical line at x equals negative 2. And the last step, we need to find the focus. But it's here at this point, it's probably easiest for us to draw the graph. So let's draw a quick sketch of what we've got here. So we know our vertex is at negative 1, comma 2. So when we draw our sketch, go negative 1 on our x, we'll go up 2, we'll plot our point. I'm just going to use a V to represent the vertex here. Our directrix, because our p-value is 1, absolute value of p is 1. So our directrix is only going to be 1 unit away from our vertex. So we plot our graph at negative 2, so if we slide over and go to negative 2, it's a vertical line, so I'm just going to put a dashed line right there going through x equals negative 2. And this distance from the vertex to the directrix is a length of 1, so we have to make sure we stay consistent, and the distance between the vertex and the focus will also be 1. So our focus is just going to be 1 unit to the right of our vertex. And if we look at the ordered pair of that particular point, it's going to be at 0, comma 2. So we can fill in our focus, and if you wanted to, you could just draw in a quick sketch. Our parabola is going to open up to the right because it's going to move away from our directrix. So it'll look something like this. Right, now I know it's kind of difficult for maybe you to be able to see. I'm not going to redo that part of it, but if you need to kind of just double check what you were kind of seeing there in the video, I know the glare from the lights was made it a little difficult to see. Your vertex -1, 2, directrix x equals -2, focus 0.